Hi, you're welcome to GMAT class. Um, Today we are going to be looking at some questions under indices, and I've selected some questions for this class. And I observed that students have problems when answering questions, in external examination. Now you discover that even brilliant students, they're supposed to have distinctions in mathematics. You just see them having credits, which is not supposed to be. Now, what is the problem? Now, the problem most students have is because they don't really know what the examiner wants from them. Now, let's take for instance now indices. If you are given a question under indices, what the examiner wants to check is, do you know the topic indices? That's one. Two, do you know the principles that guides indices? And also, do you know how to apply that principle to a real life problem? So those are the things that I expected from students. So, but we observe now that students, they just make an assumption in their mind that the examiner should know. They know. They are just after getting the answer. But in mathematics, the steps taken to get your result is very, very important. It's much more important than the answer that you're going to be having. So, what am I trying to say now is that as a student that want to write exam, you must understand the principles that guides the topics that you are doing. If you are doing indices, you should know the principles that guide it. And when you are solving problems, you make sure now that those principles are well spread out. You apply it. You don't jump steps. Most brilliant students, they jump steps because they are brilliant. They believe that, okay, the examiner should know. I used to tell students, if you know you want to have a distinction, you should assume that the person that will mark your script do not have idea of mathematics. So you should try as much as possible to be simple in your workings. Don't jump steps. Everything line by line. Make sure there is a connection between all the steps. So the questions that we are going to be doing today, I carefully selected them, and I want us to go through it and how you expected to answer questions under indices. Now, let us solve the problem we have here. Now, the first example we are going to be looking at is this. Solve the following equations. First one, e raised to power 3 raised to the power of e plus 1 plus 3 raised to the power of e equals to 108. Now to solve this, I will write the question. 3 raised to the power of e plus 1 plus 3 raised to the power of e equals to 108. Now the first thing is to adjust this. I'm going to be using one principle, one law of indices. Now, the law says if we have a raised to the power of x plus y, the result will be a raised to the power of x times a raised to the power of y. So this is the law that we are going to be applying here. Okay, so now this equation now turns to 3 raised to the power of e times 3 raised to the power of 1. Here now my e is x and the 1 is y. Okay, so equals to 3 raised to the power of e equals to 108. Okay, so here we can make an assumption. Say let p be equals to 3 raised to the power of e. Okay, so now this equation will now turn to wherever I see 3 raised to the power of e, now I put p there. So this equation turns to p times 3, p times 3. P, this is P times 3. That is going to give you 3P. So I have 3P equals to, oh, now this is supposed to be plus. So this is plus 3 raised to power of E here is P. So that is going to be P. So we have P here equals to 108. All right. So you can add this together. We have 4P equals to 108. All right. So when you divide both sides by 4, you have, let's do that. 4P divided by 4 equals 108 over 4. So 4 cancel 4. We have P equals to 4 goes in 10. That is 2. It's going to remain 2. And the 4 goes in that. That's going to be 7, right? Okay. So now this now becomes, we have this to be e raised to power 3 raised to power of e. So we have 3 raised to power of e equals to 3 raised to power of 3. Now, hope you know how we got here. 3 times 3, 9. 9 times 3, 27. Okay, now the bases are equal. So the power 2 must be equal to preserve equality. Right, so we now say therefore E equals to 3. So that's going to be the answer to this question. Now, if you have to award mark to this, how do we award mark? Now look at here. You have applied one law of indices here. So there will be a method mark for that. If you jump this mark has gone. So now for getting to this level, you have M1, and for having this equation, we have M1, and for equating the power, we have A1. So it's a 4-mark question. So that's the first part of the question. Now let's look at the second part. Now the second part, we have 2 raised to the power of m plus 2 plus 2 raised to the power of m plus 1 plus 2 raised to the power of m equals to 56. Now look at it. Just like we did here, we are going to apply the same law on this. So this equation now turns to 2 raised to the power of m times 2 raised to the power of 2. Hope you get that. Okay, this is law of multiplication. So plus 2 raised to the power of m times 2 raised to the power of 1 plus 2 raised to the power of n equals to 56. Right? So you can see. Now you can now make an assumption. Let P to be equals to 2 raised to the power of n. So this will turn to P, this turns to P, this turns to P. So if this is P now, it's going to be P times 2 raised to the power of 2. 2 raised to the power of 2 is what? 4. Good. So we'll be having P times 4, okay, P times 4 plus this P, right? P times 1. 2 raised to the power of 1 is 2. So P times 2, P times 2, okay, you get that? So the next one is plus P equals to 56. All right? So here you can multiply this to have 4P plus 2P plus P equals to 56. Now, when you add this and this and this together, you have 7P. So you have 7P equals to 56. So you are going to divide both sides by coefficient of P. and that's 7. You have P equals to 56/7. P equals to what? 8. All right. Now, from here, you can come back here and insert the value of P. That's 2 raised to the power of n equals to 8 is the same thing as 2 raised to the power of 3. 2 raised to the power of 3. Hope you know 2 times 2, 4, 4 times 2, 8. Now, the bases are equal. So that means the power 2 are the same thing. So we have to say, therefore, n equals to 3. And this is going to be the answer to the second question. Now, how do we award mark? You have applied law of indices here. So there will be a method mark here for applying that law of indices. Okay. Now, you have done some simplification down until you get to this place. There will be a method mark 1. For getting this answer, there will be an accuracy mark 1. And here, for substituting, there will be another method mark 1. And for getting your answer, you have another mark, accuracy mark 1. So the total marks for this question will be 1, 2, 3, 4, 5. So 5 marks. So 5 marks. So you can see how you expected to solve this kind of problem. Now let us look at another example. Let's look at another example. Okay, but then before we do the next example, I'm going to give you a question so you practice. I want you to practice. It's similar to what we have done. Let me have your answer in the comment section. Try this one. Try this one. So 3 raised to the power of p plus 1 minus 3 raised to the power of p equals to 54. Okay, so you solve this. Okay. Now let's look at the second example, example 2. So while I'm writing the next example, you can make an attempt, solve this problem, and let me have your answer in the comment section. Right. Example 2. Solve Roman numeral 1, 5 raised to the power of 2 raised to the power of r, and Roman numeral 2, 3 raised to the power of 2 raised to the power of x plus 1 equals to 729. Okay, so that is going to be that's the question. Now, before we solve this, so I want to know where you are watching from. You are just joining this platform, so let me know where you are watching from, and if you have not subscribed to this channel, you can subscribe so that you always have the updates anytime I'm online. And also, I will want you to drop uh, your answer for this problem. Let me see what you have before we go into this. Okay, I think some of us are still working on that. So now let's solve this problem. Let's solve this problem. Now the first one we have here is 5 raised to the power of 2 raised to the power of r. Okay. And this is equals to check it, equals to 625. 625. So 625. So this is the first one. Equals to 625. Now let's look at this question. Now the question looks scary, but it's so simple. Very, very simple. Now, when you have this type of question, now the first thing to do now is just look at your right hand side. You express the number there in its index form. So I'm going to be expressing this one in its index form. All right, it's a multiple of 5. Is 5 raised to the power of 4. 5 raised to the power of 4. So I'll be writing 5 raised to the power of 2 raised to the power of r. So this is the only one changing now to this. Now you can see we only have base 5 here and base 5 here. So the base are equal. Now it implies that the power 2 must be what? Must be equal. So we now have 2 raised to the power of r equals to 2 raised to the power of r equals to 4. Okay? And the 2 raised to the power of r is the same thing as 2 raised to the power of 2. This is 4. So since the bases are equal, we can equate the power. The powers. So say therefore r equals to 2. So that is going to be the answer to the first part of the question. Now let us look at the second one. But before we look at the second one, let's see how do we award the mark. Now look at what we have here. You have expressed this one in index form. For expressing this in index form, there's a method mark. Okay. For equating the powers, you have equated the powers. So there will be another method mark. Okay. Now this has been expressed in index form. So we have another method mark and we have the answer A1. So it's 4 marks question. Okay. So now let's look at the second one. What do we have there? So the second one, we have 3 raised to the power of 2 raised to the power of x plus 1. Okay, that's what we have at the left hand side. The right hand side, I said it earlier, you find a way of expressing this in its index form. You see, what comes to mind is I will look at the base I have here, because what would bail me out is if they can have the same base, so that I'll be able to equal the power. So I'll begin to look out for a multiple of 3 that is going to give me this. So 3 raised to the power of 6 should give me this. Okay, so I will have 3 raised to the power of 6. 3 raised to the power of 6 is going to give you this one. Okay, all right. So now, since the bases are equal, so you can equate the powers. Now let's equate the powers. So when you do that, you have 2 raised to the power of x plus 1 equals to 6. Now look at this side. You can see you can't express this one as a multiple of 2 here, as in its index form. So now what you are going to do, now let's split this. We have this as 2 raised to the power of x. We are applying that law of indices times 2 raised to the power of 1 equals to 2 times 3. Okay? So you can divide both sides by 2 now. So you divide this by 2, this by 2. So we have 2 raised to the power of x equals to 3. Right? Now here, since this cannot be expressed as power of 2, now we are going to apply logarithm. So this is an indicial equation. So you turn it to logarithmic equation. So now let me show you this. If you have x raised to the power of n equals to m, this is a rule. Now, if I this is an indicial equation, if I want to change it to logarithmic equation, because now this is the base, this is the power, and this is what? And this is the number. All right. We now say log of m to the base of x equals to the power. All right. So you can see this is the base, this is the power, and this is the number. So what will happen to this? The base will come down. This is the number will be here, and then the power will stay out there. So this one will turn to log of what? Log of 3 base 2 is equals to x. So that's what we're going to have. All right. So that means x is the same thing as this. So now, this should be the final answer, but we can solve further. So now using change of base. So this is x equals to log of 3 base 10 divided by log of 2 base 10. Okay, so and then we have x equals to, now log of 3 base 10 is a common number, that is 0.4771. So you should be familiar with that. Log of 2, that is 0.3010. Okay, so you can divide. So when you divide, what do you have? That's 0.4771 divided by 0.3010. So x will be approximately 1.585. 1.585. So, or you stop here. Okay. So now that's going to be the answer. So now, how do we award mark here? Now, for equating the powers, there's the method mark, that is M1. Now, we have divided both sides by 2. There will be another method mark here. Okay. And then for getting this answer, A1 accuracy mark. And then also for applying law of logarithm here, so we award M1 for this, for getting the answer A1. So the total marks will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So that is that. That is that. Now let's move on to the next example. Let's move on to the next example. And this is example 3. And let's move to example 3. Example 3. So for D, if 5 raised to the power of D minus 5 raised to the power of minus D over 5 raised to the power of d plus 5 raised to the power of minus d is equals to 12 over 13. Okay, so that is the question. All right, now let us solve this problem together. Now look at this question. I can see something here. I'm going to apply law of indices here. Now look at the law. The law says when you have x raised to the power of minus n, the answer is going to be 1 over x raised to the power of n. So that's what I'm going to be applying here. So now this left hand side will turn to 5 raised to the power of d minus 1 over 5 raised to the power of d. So I've applied this law here over 5 raised to the power of d plus 1 over 5 raised to the power of d. Now, what I've successfully done is that I've expressed everything here as 5 raised to the power of d. 5 raised, so there's no longer 5 raised to the power of minus d. So from here, you can say let y be equals to 5 raised to the power of d. So if y is 5 raised to the power of d, so that means this equation will turn to y, this is now y, minus 1 over y, minus 1 over y, all over, this is y plus 1 over y, okay, equals to what? 12 over 13. Now here, you can cross multiply. So when you cross multiply, this times this, so we have 12 times y plus 1 over y equals to 13 times everything we have here. That's y minus 1 over y. Okay, so now let's open the brackets. So when you open the bracket, you have 12y, 12 times y. So 12 times 1 over y. That is going to be plus 12 over y, okay, equals to 13 times y, that's 13y. So you use 13 to multiply this, that's minus 13 over y. Okay, so now let me move this to this side. I'll move this one here. The fractions can move to this side. So I have 12y minus 13y equals to minus 13 over y minus 12 over y. Okay, so what you have here now is minus y. Now 12y minus 13y, that gives you minus y, right? So is equals to minus 13 over y minus 12 over y. And what do we do next? We multiply through by minus y. We multiply this one by minus y, this by minus y, this one by minus y. So when you multiply this by minus y, this turns to plus y squared, because minus times minus is plus. Y times y is y squared, equals to, multiply this one by minus y. Minus times minus, this one will have turned to plus. So the y will be at the top. That y will cancel this y. So what you will left with here is going to be 13. And here too, we are multiplying this one too by minus y. So minus times minus, that's plus. So the y will cancel this y. So you are left with what? 12. So you now have y square equals to, now when you add this and this together, you have 25. Okay, so from here, From here, we now have y squared minus 25 equals to 0. That's the same thing as writing y squared minus 5 squared. Okay, so using principle of difference of two squares, when you have a raised to the power of 2 minus b raised to the power of 2, the result is going to be of two squares. Square 1, square 2, subtraction of two squares will be expressed. So now this one is subtraction of two squares. So we have this to be y minus 5, y plus 5 equals to 0. Now, as you can see, these two things are multiplying each other to have 0. So it's either this is 0 or this one is 0. So we have y minus 5 equals to 0 or y plus 5 equals to 0. So y equals to 5 or y equals to minus 5. Okay, so in this context now, y cannot be a negative number, right? You can see our y now. Y is 5 raised to the power of d. So now we have 5 raised to the power of d equals to 5 raised to the power of 1 for this. So we now write what? Therefore, d equals to 1. Since the base are equal, you create the power. Because here, if you use 5 raised to the power of d, then this one is equals to minus 5. That will not be valid. There's no how you'll be able to get the answer, right? So the solution does not exist in real number. So you have to discard this. So the solution is p equals to 1. So that's going to be the answer to that problem. All right, if you are just joining class, I want to know where you're watching from. Let me have a comment based on the class, and you know also share this video with your friend. If you are just joining, if the class is interesting to you, you can as well share it with your friends.